This is a great crowd this year. If you look back a few years, it's absolutely amazing how far we've come. So I went on a little field trip a couple hours ago with Mikey Dickerson and Mike Flowers to Starbucks. I need to warn you, I am quite caffeinated right now. So look out, and being that I only have 9 minutes and 36 seconds, that's probably good. All right, folks, it's been a great year. Thanks for giving me the opportunity to come back again. Big news, and part of it's already been stolen. I joined the board of Code for America, and that's super great. It's a real honor. I've continued to work with the University of Chicago at the Harris School of Public Policy, and our big launch this year, which is happening now, is a year ago I talked about a dual degree in computer science and public policy, and that has now launched. This is an effort to take the sort of graduate programs and also the people we have been working in government to the next level, bringing together these worlds we know so well and codified in a program. So really, really exciting year. So a year ago, when I got up before you, we talked about Beyond Transparency. And great book, great launch, really excited about it. And I was really proud of where we've come with open data. We went from being a little niche to being something that was codified, and there are executive orders and laws, and data's going out the door. And when you look at examples now, like what you're seeing up on the big screen is San Francisco crime, and it's out there, and that's great. But as I spoke about last year, how do we take the challenge even further? So 2 years ago, I talked at the Aspen Institute, and if Dan O'Neill's out there somewhere, Dan, okay. He remembers I spoke about spreadsheets on the web, and the danger with open data was we would put out all of this data, but would it in fact be usable? And how would we go further with this data? And I talked about this idea of how do we unify the data so it's no longer spreadsheets on the web, that there was one way to query it, that there was a single-stop shopping for all of this data, and we stopped worrying about data work and instead worried about information. So I'm fortunate that I have a friend. Now, here's the truth. I actually don't have a lot of friends. But of the, I actually don't think I can use two hands. On the friends on my one hand, I have a really good friend, and his name is Charlie Catlett. He's a fellow at the Computation Institute at Argonne, and he and I have partnered on a number of projects. So I talked to Charlie, and I said, maybe we should build a solution to this problem. And he said, maybe we should. I'm a computer scientist. You're into the computers. You know about public policy. How can we develop solutions to this? Now, even though that we have a good partnership, we're fortunate. We have more than just me and Charlie. We had a team, and team from all different sides of things. CS folks, public policy folks, civic hackers, and said, how can we get open data and make it more useful? How can we have one-stop shopping? How do we, I think I mentioned this last year, I had a journalist come to me and tell me, open data is too hard to use. I can't get anything of value. Can you tell me the information within that? So what would a solution look like? So we wanted to get at a few pieces here. We started by this idea of a central data store, followed by how do we take all of this different data? Because remember, I am typically focused on the story of place. Because as you're working in cities, as you're working in government, municipal, state, local, federal, you need to know the story of place. And that place isn't about department, it's not about jurisdiction, it's about the totality of all of the information. So, but at the same time, how do you get at the different types of platforms that are out there? We have Secreta. They've been a good partner to the city of Chicago. Clearly CCAN. And then you have the random data systems that are up. But at the same time, how do you build a single API? Again, one-stop shopping. So within that API, it needs to have a single spatial index. You want to have the total story that if you offer a coordinate a latitude and a longitude, that you know the full story. But space alone doesn't always matter, and people always hear me talk about spatial temporal attributes. You need to have the time series attributes of this. But at the same time, there is data that I haven't mentioned. And one thing I will call out is weather data. How many people here have worked with weather data? How many people here have found it easy to work with weather data? Don't do it. OK. Weather data is hard to work with, but yet it's copious. One, it occurs every day. It occurs every hour. It's always there. And we have a wonderful agency, NOAA, who collects it. Yet there wasn't a lot of enthusiastic people jumping up and down, saying, I can work with that data easy. And it's not a problem, and it's a piece of cake to integrate. So we looked at this and we said, how do we take all of this open data? How do we take high-value data sets that are large and that are complex, like NOAA data, and bring them together? So today, I'm really excited to be able to announce the alpha version of a product we call Planaria. And Planaria is the culmination of, honestly, a lot of work. And I've been really nervous about today. So what does Planaria do? It does everything I said before. It brings together all of that data. And then if you look to the right of your screen, let's give the simplest example for your typical user. You can draw a shape. You can draw a polygon, whatever you want, wherever you want, and it shows you all of the data available with whatever time bounds that you want. OK, so maps are great. We like maps. Those are kind of pretty pictures, but it's important to have that. But the beauty behind Planaria is it's all about the raw data. There's a single API, and we offer up all of this rich, updating data via the API. And it's machine readable. On the left side, you see JSON. And that is the true value of this. While it's easy to use in one regard, it offers up whatever you need on the other side. Now, I am going to do now exactly what you should not do when you're giving a talk at Code for America, which is encourage you to do a live demo. And this is actually banned. So at any moment, Jen's going to come out here and give me the hook, but I'll be like, I'm on the board. What are you going to do? So here's a query, and we actually have to go really fast. So pull out your laptops. Hopefully the interwebs are working. And then we put a short URL up there. So here's a call which is calling the crimes data. And for those of you that know me, know that's a data set that's near and dear to my heart. It's calling all of the crime data in Chicago. And it's saying, let's look at everything from January 1, 2014 going forward. And guess what? Let's focus on homicides, because, again, this is an area of interest to me. But at the same time, let's add the weather data in. And remember, weather's impossible. So when I look at these projects academically, I'm like, oh my God, I have to join the weather data to crime. This is going to take, I'm not going to do it. I'll have a research assistant do it for the next couple months. And they'll have a good time. See, I have an RA in the audience, so I think she'd really enjoy that. So run the query. And, the magic of PowerPoint happens. And here you go. See, there you go. Thumbs up. Live demo works, survived part 1. So here you have the data, and as you can see, it's performant. We are giving you the joined data as you want it, as you need it. And now we really have to pick up speed because I'm already in the yellow. So it brings together, in this case, what you're looking at is homicide data with the attributes of the weather at the incident time. The value of this is enormous. It's a game changer for research. It's a game changer for media. OK, let's do some more examples. People, come on, laptops. So if you go to Planaria examples, so I've given you some sample code there. Now, the riskier thing I did, because risk is good, is I'm letting you, if you pull up the web page, edit the queries. So go crazy. Do it. What are the kinds of questions we want to answer? Well, we know about 700 Howard Street. That's interesting. A weekly count of all 311 requests in every city in the country. Or the traffic accidents in Manhattan where there was a fatality. And what was the weather like during the incident? All of these examples are there. You should try them. You should edit them. You should try and break it. It's there for you to do that. There's a reason it's all in GitHub. Now, we're going super fast. these tools are meant to be extensible. The idea is we as Code for America, we as a community need to stop building tools that only work in one jurisdiction. By unifying this data and bringing it together, we're able to build tools on top of the API that work anywhere. The data's there. There you go. Okay. So in this case, you're looking at a choropleth for 311 data. Great. Works well in Chicago. Will work just as well in any other jurisdiction. Open up the data. Planaria hooks into it. We ingest it. One tool, one solution. And that leads to savings, efficiency, and better performance in our various jurisdictions. So I encourage you. We built the API. You build the apps. Let's work together to build on top of this platform. Move the whole idea of open data from being these siloed little entities into one architecture, one system. Now, where do we want to take this? Turbo. So fixing, if you read the New York Times, if you read the articles, everyone talks about how data is so hard to work with, that 80% of your work is data prep before you can actually do the real problems. We need to move the needle on that. We need to focus on real solutions for real people, for real problems, not on data prep. That is why investing in a solid foundation and architecture makes enormous sense. We need to take it to the next level where we are focusing on making a city smarter, where we are preventing rather than reacting. Now, because I'm out of time, I have to skip the fun part, which is a super cool master table, which works really well, so it's good. We'll talk later. And at the same time, though, I definitely want to call out the support. I'm funded by MacArthur. I have an excellent program officer, Elena Harkness, who I think is here. Thank you, Elena. The National Science Foundation gave us an eager grant to work on this project. This is a project that was out there. It was higher risk. But we got the support, and there's vision, and we're able to actually work on these things, which take this initiative to the next level. And it was a combination of support of University of Chicago, a company DataMade you heard from Derek Eater earlier on, and I definitely want to note, because I'm very supportive of cloud-based architectures, our Amazon AWS architecture, which I'm really proud of. So thank you very much. Try Planaria. I appreciate it. I want to hear from you. Try and break it. Commit. Thank you.